All right, so let's take a look at this new piecewise function. But before we get started, I just want to point out that there's a slight typo here. This should be -4, not -1. So go ahead and change that in your notes. And what I like to do with these piecewise functions, I like to highlight it. This is a new one. It's got 3 different parts. So let's highlight each part in different colors. So like, I'm going to call this the yellow part. I'll call this the green. And I'm going to call this the blue. And what we're going to do is we're going to think about what these numbers here mean. Remember, this is the domain column. This tells us where it's going to be graphed. Where is it going to be graphed? So for the yellow one, it's saying it's going to be graphed from -infinity to -4. And these are all x values. So essentially you can see like, okay, x is 0 here, -1, -2. And eventually you keep going way over here somewhere is -infinity, right? So what I like to do is on the graph is actually like highlight where is -4 at? Like where does this thing end? And it's right here, isn't that line right there where all the x values are -4? And forever that way, because it's always till -infinity, is where the yellow graph is. But then at -4, that's where it stops. The yellow graph doesn't go past yellow 4 and or past -4, and right at -4 it changes. It changes to the green one. So also at -4 turns green, and it stays green till +2, which is right here. So green is going to be in this window and only this window. And then at 2, it changes to the blue one. And so the blue one starts and then it goes on and it goes till +infinity. So it's going to go forever that way. All I'm doing is kind of giving myself a little view of when this thing changes. And something kind of important here that I kind of didn't note really well in my thing is there's a hard bracket here, right? These are all parentheses. But when you see that hard bracket, that means that we're included too. So I'm actually going to go back and, oops, I meant to use the highlighter, and highlight over this again with green and just say, you know what, remind myself that actually it's included here. So let's go ahead and do this. Let's graph this thing. So 2x plus 3. Now there's a lot of things that I could do here. And if you don't know how to graph a certain function, if you're at all unsure how to graph a certain function, what I recommend is that you make a t-chart. Let me show you how you can do that. So here's your t-chart, here's your x values, here's your y values. And on this graph that I have drawn here, obviously if that's 0, we got -1, -2, -3, -4, right? Where the graph changes, -5, -6, -7. And so we really only care about from -7, and that's +7. So we could actually just, this is the slow way of graphing, but it'll work 100% every time. I'm going to just start at -7 and go up by 1. Okay, and there's all the x values on this whole graph, right? This is -7, -6, all the way up to +7. All right. And remember, we said that the yellow one goes from -infinity to -4. So again, I'm going to get my highlighter out, and I'll say, you know what? Those -4 ones and below, those are all going to be yellow. So that's going to be yellow numbers. Oh, and I forgot one little thing here. When you number all these like this, you actually want to, anytime there's a transition, -4, see how there's -4 shows up in both of these and 2 shows up in both of these? That means you want to write that number in there twice. So I need another -4 and I need another +2. So we'll do that real quick. It won't look pretty, but that's okay. Just make it work. All right. So then let's highlight the next set of numbers, because the next set of numbers goes from -4 and includes +2. So I'm going to highlight from -4 all the way to the first +2. All right, and those will be the green function. And then everything that's left is going to be the blue function, because the blue goes from 2 to +infinity. All right, this is the part, if you can just make this t-chart, this is going to be so easy. All you need to do now is take the number, for example, -7. It's part of the yellow function, so we plug it into the yellow equation. So what happens if I plug -7 in for x? So if there is a -7 there, -7 times 2 is -14, and -14 plus 3 is -11. Boom. So that means, and that when you plug in -7, you should get -11. Let's do the -6. Same idea. -6 times 2 is -12. -12 plus 3 is -9. Let's plug in negative 5. Plug in negative 5 times 2, that's negative 10, plus 3, that's negative 7. And lastly, the last number in the yellow is negative 4. So if I plug in a negative 4, that's 2 times negative 4 is negative 8, plus 3 is negative 5. Okay, now I want you to look at these numbers real quick here. Negative 11, negative 9, negative 7, negative 5. There is a pattern there, and you could probably see what is the pattern, what's happening each time. Well, they are increasing by 2 each time, right? Because we're at negative 11, then we're at negative 9, and it's going up by 2. Well, that's because if you look right here, the slope is 2. Remember, this is just a line. If you remember back when we did equations of a line, which you did in Math 1 or in Algebra 1, m was the slope. Well, look what your slope is. It's 2. So even if you don't do the 2 chart, you could still kind of see what's happening here because you could see that it has a slope of 2, and actually it would have a y-intercept of 3, except for, does the yellow part ever touch the y-axis? It doesn't. So essentially what we're saying is it's going to go, it's a line that's going up by 2, and if we could get all the way to 0, which is right here, it would hit this line at 3. It would hit right here. But it's not going to reach there. It's going to stop somewhere over here. So look at the yellow. All we have to do, guys, I know it seems like this is too simple, but literally all we did is we plugged in those numbers and we wrote what we got right here to the right. Boom, 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 boom. Well, now we just have to plot these points on the graph. So where's negative 7, negative 11? It doesn't even fit. It would be, this would be like negative 8, negative 9, negative 10, negative 11. So it'd be like right here, okay? So it doesn't even fit on our graph. And then the next one is negative, so we got that one checked. Negative 6, negative 9, that would be like right here. And then finally we're at negative 5, negative 7, which is right here. And then the last one is negative 4, negative 5, but this is an interesting one. Because remember, if you look at this thing right here, that parenthesis, that means that it's not actually included. And when it's not included, we do an open circle. So at these borders, whenever there's a borders, we really have to think about, okay, is it an open circle or closed circle? And border is what I mean when it goes from one function to another. So like, see, we have a transition at negative 4, and we're going to have another transition at 2. So when I get to negative 4, I'm not going to do a normal dot. Right? It's negative 4, negative 5, but it's going to be an open circle. So negative 4, negative 5, I do an open circle, and this is a line, boom, boom. And you can see, if this line was to keep going, it would go up by 2, up by 2, up by 2, up by 2, until it would hit the y-axis at 3. But it doesn't go that far. It stops at negative 4. It stops right here, and now we go to the green function. Okay? So now we're going to do the same thing with the green function. We're just going to take these numbers and we're going to plug it into the green. That's it. So first one is negative 4. Negative 4 squared. Negative 4 times negative 4 is positive 16. Negative 3 squared is positive 9. Negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay. So at negative 4, we're up here at positive 16. It doesn't even fit on the graph. Maybe we should have used, I don't know, different numbers or something. But somewhere way up here, I'm not even going to draw it, there is a point at negative 4, 16. Well, okay, I'll kind of draw it. It's somewhere way up here. I'm just going to kind of sketch it. And it's an open circle way up there. Why is it an open circle? Again, that's a parenthesis. That means it's not included. Whenever it's not included, it's an open circle. So that point right there, negative 4, 16, is an open circle. We only care about the open and closed circles at the borders from one function to the next. Okay, negative 3, 9. Well, that we could get to. Here's negative 3, 9 would be like, remember, this only goes to 7, so 8 and then 9. So we're kind of just going to add a couple little tick marks in, and boom, there's negative 3, 9. And then, and I know this is not to scale, but this is supposed to be, remember, this is supposed to be negative 4, 16. Okay, so I got negative 3, 9. The next point is negative 2, 4. Okay, that's going to be a lot easier to graph. That's negative 2, 4 right there. Then the next one is negative 1, positive 1. The next one is 0, 0. The next one is 1, 1. And I've graphed all these. And the last one is 2, 4. But now this matters because when the x value is 2, now we have a hard bracket. The hard bracket means that it is included there. It is a part of the function there. Remember, the soft means it's not included. So when it was Not included, we did open circle, and now that it is included, we're going to do this hard bracket. So I'm going to do the hard bracket, which means that it should be a solid dot, a closed-in circle. So at 2, +4, I'm going to put in a solid dot. So this sketch looks something like this. Remember, this point up here it actually should be way higher. It's not to scale. The rest of them are in the right spot, but that one's not. And so this green graph ends right there with a solid circle at 2, 4. Okay, now we are ready for the blue one. So we're going to do the blue one now. And the blue one is pretty simple. All the blue function says is you take your x and you switch the sign. So we could do that. So if we put in a 2, it should be -2. If we put in a 3, it should be -3. That would be -4, -5, -6, and -7. Easy enough. But look right here. For the blue, when we start at 2, it's a soft parenthesis, which means that it's going to start with an open circle. Again, the open and close only matters at the borders. A lot of students get confused about that. It only matters at the borders. So right here at 2, -2, which is right at this point right here, I'm going to do an open circle. The rest are all just normal points because they're not on the border. So 3, -3, 4, -4, 5, -5, 6, -6, and 7, -7. And obviously this keeps going forever and ever and ever. So we just go like this and put a little arrow at the end. All right. I know that seems crazy, but it's really pretty basic. All you're doing is taking all of your x values and plugging it into the equation, but make sure you plug it into the right equation. And to know what the right equation is, you just look at these numbers. This one goes from -∞ to -4. So all the numbers that fall in there, go for this one. All the numbers that fall from -4 to 2, go in this one. And all the numbers that fall from 2 to infinity go in this one. And so we have pretty good sketch of what our graph should look like here. And that's kind of all there is to it. You just, the secret to this is to make this thing right here. And this is called a T-chart, okay? I expect to see T-charts on all your work. This is what you really need to be successful at piecewise graphs. Pretty simple to do it. As you get better and better at graphing, you may not need the T-chart because you may pick up patterns. Like you may pick up a pattern here. Like this is also a y = mx + b. The slope is -1 because there's like a -1 in front of the x, and the b is 0 because there's nothing there. So this should have a slope of -1 and a y-intercept of 0. Well, if you were to follow this all the way back, it certainly would have a y-intercept of 0. It's going down 1 over 1, down 1 over 1, down 1 over 1, down, and it's just going down 1 over 1. So you could kind of anticipate what the pattern is. This is a quadratic, it's a parabola. We'll learn about those later, but we'll eventually be able to tell what the pattern is for those too. So I think that's all there is to it. Just make your T-chart, and I think you'll be in good shape. See you guys on the next video.